When we draw a simple shape, like a circle, we can easily put it just where we want it because we explicitly give it an x and y value. But when we draw a shape with tons and tons of vertices, it becomes more of a hassle. There's a built-in transformation in processing to let us move things around, and it's called translate. The word translate comes to us from mathematics. It really means nothing more than move. So this is probably a weird use of the word translate for you, but it's a very, very common one. Everyone uses it. So just keep in mind that translate means move. Here's how we use it. Suppose I have this graphics window, and of course I have a coordinate system in the upper left, and I have somewhere a huge list of coordinates that I can call between beginShape and endShape to draw a bear. As we saw in the overview video, the bear is drawn with the origin level with his feet and horizontally centered. So we wouldn't even see the bear because it would be drawn entirely off screen when the origin is in the upper left, but in this slide we can see the bear sitting just above and to the left of the graphics window. Now if I move the coordinate system, that is, I translate it to a new place, and now I draw the new bear shows up with respect to the new coordinate system. I can do this over and over. The bears I've already drawn don't change. But every time I draw a new bear, it's always drawn with respect to the coordinate system. So let's see how to move that thing around. You won't be surprised to learn that the name of the routine in processing is translate. Translate takes two arguments. The first tells processing how much to move the coordinate system horizontally in x, and the second one tells it how much to move vertically in y. Here's a graphics window in my standard convention. The grid lines are 100 pixels apart. The origin is in the upper left, and remember that the x and y axes are being drawn really blown up. In reality, you should think of the x-axis as being just 1 unit long, 1/100th the length of this arrow, and the same thing for the y-axis. But so we can see them, I draw them super huge. Suppose we now want to move the coordinate system by some fixed value. Let's say 300 and 200. So how do we go about that? Well, this tells us to move 300 units to the right in x and 200 units down in y. So let's take those two steps one at a time. Take a look at the big black dot in the upper left. That's our origin. We want to move that 300 pixels to the right. So first we move 100 pixels, now we move another 100 pixels, and now we move another 100 pixels. Now we're 300 pixels over. Now we want to move 200 pixels down. So okay, we move 100 pixels down, we move another 100 pixels down. This is the new location of our coordinate system. And we could just draw it right there. And if we drew a bear or a penguin or anything else, it would be drawn with respect to this coordinate system. In fact, even if we drew a circle with its center at 0, 0, it would be centered at this big black dot because that is now the origin of the coordinate system. Let's see another example. I'll translate by minus 150 and minus 50. So minus 150 means I'm going to move in a direction opposite to the positive x-axis. I'm going to move to the left, and I'm going to move 150 units to the left. So let's measure that off. There's 100 units, we'll go to the left. There's another 100, but we only go halfway. So now we're 150 units to the left. Now I'm moving minus 50 in y. Y points down, so minus 50 points up. So okay, let's bring our y arrow in. We're only going to move half the distance. Now we're moving minus 50. Let's put the coordinate system there. And now we have a new origin for the coordinate system, and everything we draw is with respect to this. Now drawing all these arrows is nice, but there's a much simpler way for us to illustrate each of these translations. Here's how I'm going to do it. Suppose I want to translate 250 units in x and 150 in y. They're both positives, that means I'm going to move right and down. To show the translation of 250 units in x, I'll just draw a big blue arrow that is 250 units long. 150 units in y I'll show with a blue arrow pointed down along the y-axis, and it is 150 units long. So we can see just where the origin is going to end up. I'm going to draw two more helper lines. Take a look at the end of the blue arrow that's pointing to the right. I'm going to draw a vertical line there and drop it straight down. Now take a look at the end of the blue arrow that's pointed down at the left side of the screen. I'm going to draw a horizontal line there. Where these two thin horizontal lines meet, that is the new origin, because that's 250 units to the right and 150 units down from where the origin was. So their intersection is the point that we're moving to. And then we can erase all the little construction lines, and this is our new origin. Let's look at another example. This time I'll translate 175 units in X and minus 100 in Y. So I draw a blue arrow that's 175 units in X, and now a blue arrow that's minus 100 in Y. That means it's pointed up because it's a negative value of Y. Now I'll draw my little construction lines, and where they intersect, that's the new location of the origin. So we just move the coordinate system there, and we're set. Let's use this to draw some bears. Here's our coordinate system, and here's the code that I'm going to execute inside of draw to draw my bear. I'll assume we've already done all the setup stuff and we have a background color and all of that. And these are the 5 lines that are really interesting. You'll notice that translate appears twice and drawBear appears 3 times. What is drawBear? Well, drawBear is really nothing. drawBear is just a little routine that calls beginShape, and then it calls vertex over and over and over and over and over again for each point on the outline of the bear. And then finally, when it reaches the end, it calls endShape close and it draws the bear. All these little vertices I drew on a piece of graph paper and measured by hand and typed them all in. So let's get back to our example of using translate and execute this program. The first line is easy. It tells us just draw the bear. So okay, we'll just draw the bear. And I'll assume it's located in this position at this size when drawn with respect to the default coordinate system. So now we move on to the next line, translate 250, 150. Well, we know what to do. We draw a blue line 250 units long. We draw a blue line 150 units down. We find their intersection, and that intersection point is where the coordinate system is going. So we'll move it down there and we'll get rid of the helper lines. Processing, of course, does not draw any of that blue stuff. That's just to help us visualize what's going to happen. And the coordinate system ends up right here at the location 250, 150. Now we execute the next line. It says draw bear. The bear we drew before is already drawn. He stays where he is. But now we're going to draw a new bear with respect to the new coordinate system. And there it is. Now let's execute the next line. Another translate. This time it's 200 minus 25. So positive 200 means we're going to move 200 units in the positive x-axis. And now minus 25 means I'll move negative 25 in y, or 25 units opposite to the way y is pointing. Okay, now we'll draw our little construction lines. We know where it's going to go. There's the new origin. And we're done with the translate. Now we execute the next line. It tells us to draw a bear. No trouble. We draw a bear. And here's our final result. So by using translate, you can position bears anywhere you want. Remember that every time you call translate, processing moves relative to where the coordinate system is now. It doesn't matter if you're at the origin or anywhere crazy. You can even be off screen. Processing doesn't care. When you say translate, it just moves the coordinate system relative to where it was at the moment you called translate. That's all there is to it, but there's one thing I want you to keep in mind. You need to repeat your translations for every frame. When you write your draw routine, you're probably going to draw something like this. I mean, there's going to be calls to background and other stuff, but before you draw things, you first will be calling translate. The reason why is when draw is finished and processing puts your picture up on the screen, it forgets all of your transformations. It's as though none of them ever happened. So the next time draw starts again to draw a new picture, the origin is in the upper left corner. Now you can move it around and you can draw bears and circles and boxes and anything you want, and you can just move that coordinate system like crazy within draw. But as soon as draw is finished and it goes away, that origin goes right back up to the upper left. So at the beginning of every frame, the origin is in the upper left. Draw does not remember it from one frame to the next. If you forget this, you'll see the results immediately. And it will drive you crazy. Why aren't my objects moving? And it's because draw forgets from one frame to the next. Now that you know about Translate, you can easily make a picture like this from our overview video. Just have a little routine that draws an object, and draw a whole bunch of them using Translate to put each one where you want it.